last episode, we talked about on-wing performance with emphasis on reliability of the components to reduce associated costs. But once the components are removed, then we go into repair, overhaul, modifications, and all the things that deal with off-wing support. So today, that's what we're going to deal with is the actual off-wing support when components actually do get taken off the aircraft. And I'm gonna say right now, like, this stuff is like most mechanics don't deal with, but this is kind of like the career progression. Like, once you actually get so good at being a mechanic, this is like the next step for you.
Well, yeah, I think it's good. You know, most mechanics don't have to deal with this, but it's good to know what the processes entail. Just because, you know, you take the part off and then it disappears, but you're sitting there questioning, "Where's my part at? Where's my part at?" Maybe you don't understand how in depth it can really be. But as Six alluded to as well, as you become a more senior mechanic or stepping up into the next role of control or whatever else, I mean, you are going to have oversight into these off-wing management processes and repair cycles. It's just the nature of the beast,
right?
Because you're going to be the one tracking parts for your lower level guys, right?
Mm-hmm. So like, this is the next step for like, you're dabbing your feet into the water as a lead. You're dabbing with that as a first line supervisor or a mechanic shop supervisor. But if you're ever become a director of maintenance or a control chief, this is 100% your life, because this is how you determine like how much manpower you need, how much lead time you need for a certain aircraft, when can you schedule aircraft maintenance and aircraft operations, all this stuff. It all dials back to this off-wing stuff. Because,
right. Or let's just say you even have your own supply chain department, right? You're a big enough organization that you have your own supply chain, but when you go call and supply the warehouse, right? Hey, where's my parts? What's going on? What's taking so long? What's going on with this? And they're going to explain to you a lot of what we're going to cover today. And, you know, most of the time it's in one ear out the other, but at least with a little bit of this, you'll have some understanding as to what, when they say certain things, or it's at this location, or we're awaiting this back from the manufacturer before we can issue the part back out, right, or whatever else, then you'll have a better understanding.
Right. And most operators that have well-defined supply chains and inventory management, their procedures in place to manage these processes are relative to logistics, transportation, turnaround time, even repair costs, obviously, shop reporting and receipt inspections. Those are the best place to retain control over the component and its related costs. So, like, as we're saying, especially with the receipt inspections, that's how you determine if the parts they even gave you were good in the first place. And that dives into all slew of other things, like when can you say a part's bad from the time you receive it, you know?
Right. So first section here is repair cycle. I think a lot of seasoned AMPs or maintenance personnel from around the globe understand what a repair cycle is. But for those of you who don't, I'll go over the various steps or categories better, just so you all have a better understanding. So the repair cycle of a component is further classified into the following categories: repair cost and overhaul cost, turnaround time, fill rates, scrap rates, no fault found, rogue units, and system obsolescence.
Ooh, I mean, that's a pretty big chunk of cake right there already, especially when you start going into fill rate, scrap rate, and then system obsolescence.
Yeah, I mean, that's definitely for those who are turning birds out as they're getting well, like, shoot, even in some of the corporate realms, right? A lot of the newer birds are coming when you update your maps. It's done by USB, but there's still a lot of birds out there that are operating off of a floppy disk. So, like, I never thought I would be buying as many floppy disks in my life as I did when I was doing that. So, and you would have to go buy a floppy disk, etcher. I don't even know what the hell you want to call it. It's been so long now, but essentially you plug it into your computer, and then you put the floppy disk in there and you transfer the files onto the floppy disk. take the floppy disk to the bird, and there's 1 through 9 typically, and you have to put them in, and you're going through the sequence of steps to download it, and you get so much percentage, it'll stop, pull that out, put number 2 in, 3, 4, and so down the line, and it never fucking fails. You always get to number 9, and you're at 98%, and it's like floppy disk read error, and you're like, no, the file was corrupted or whatever. So you gotta, but you can't reuse the floppy disk. They tell you can recut floppy disk. Just don't waste your time. Just go get another set of floppy disks and cut a whole new set and start over and be like the rest of us and cry in the cockpit while you're redoing this job.
And floppy disks, those are very small as far as storage is concerned, right? Like,
they can't hold hardly anything on them.
Yeah, like some of us, we remember those days when 16 bits was a lot, 16 bits, 32 bits. I think nowadays most games don't even operate in bits anymore. They all operate in bytes, if that. Like, as a reference point, like if you have any guys remember the original Oregon Trail, that was like that was an 8-bit game on a large, soft floppy disk. And then loading maps that planes rely heavily on. You're doing these harder disks that are 16 bits, and you're doing 9 of those, right? So let's do a quickie math. That's like, 100 some bits. Nowadays, you got a USB drive that can download a whole ass computer onto it, and it's like fits in your pocket pretty much. Well, like the size of your thumb for the most part, hence thumb drive, I guess, or whatever. I'm a loser. I'm a loser.
Like every time I get into a new and why is that, right? Because to upgrade from the floppy to the USB, at least a few years ago, was about a $10,000 job,
right?
To do that, and so most operators, I mean, who had like the one operator I was with at the time that had some of those jets. I mean, they had 400 aircraft, and at least 250 or so had that style. I mean, what's 10,000 times 250, like that's a lot of money to spend when if the mechs out there can just continue to make it work every 30 days, then that's what they'll do.
Right. Yeah. You're looking millions right there easily. And that's assuming that everything goes right the first try. That's another thing when it comes to mods, just going on a tangent here. But when you go into mods, right, there's always that risk or you might break something on the way in, or the mods themselves are not, especially if they're prototype mods, like this is like, we're going to try this out to get the fit. They may not go in as they should right away. So then they have to take it back out and go back to engineering and do whatever they got to do to try to make it fit. And you can do this 4 or 5 times before you finally get it right. And then this is going to be costing a lot of businesses their money each and every time they do it. And then it doesn't fit or it doesn't work the first try. So on a tangent on that one, that can be a whole nother episode of itself with mods.
Yeah, no worries. Well, we can maybe, what was her name?
Coyote.
Coyote. Yeah, we could bring her back in for that one.
Oh, definitely.
She spent a lot of time doing mods.
Oh my gosh. I remember one of the stories she was saying, man, just some of the off-show comments she was telling us, like, Jesus Christ, man. Like, I
think about that story all the time, and I laugh just as hard as the first time. I'll never forget that day. I'll never forget that story. Oh my God. I wish we had recorded that.
Right?
That was so funny, man. So kudos to Coyote.
Kudos.
All right. So back on the subject here. It's no surprise to me that the first category in that list of the repair cycle is repair cost and overhaul cost. As we've said 100 times, money drives everything. So repair cost and overhaul cost need to be defined for the context of the following considerations. Repair means making an item serviceable by replacing or processing failed or damaged parts. Overhaul means returning an item to the highest standard specified in the relevant manual. For those that didn't know.
Yeah. Now, repair and rework are not exactly the same thing. Right? Because a lot of times you hear, rework, that means repair. Yes and no. Depends. It depends. Right? Because most times when, like, say, you go to install a part and you use the wrong size screw, technically it's wrong. But if you were to replace the screw, that's considered rework, right? You're just putting it back to how it should be. Right. Now repair is like you straight up dropped it, or you went to plug it in and it fried itself. That's a repair. So, because that used to confuse me so much as an oncoming meg. Like, what's the difference between repair and rework, and why is one cost more than the other? Nah. A lot of times on the line, we kind of sort of figured out, okay, I got it. And then
Right.
go on.
Oh, I was just going to say, how do we decide though, right? How do you decide whether, in this instance, a repair or overhaul, and we can throw a rework in there too, right? What's that decision, or
Right.
what's the decision process to determine whether you should repair, overhaul, or rework?
Mm-hmm.
So it says, an overhaul by definition will always be the most expensive solution, since the work scope will always be higher or equal to a repair. However, an overhaul may prevent future events by finding problems earlier. So, in the event of a repair, well, no, never mind. It's just an example of how. So I guess how in depth are you looking at this component or sections of components, right? Maybe you had a seal fail. Okay, so you replace that one seal, but what if it's something the next stage down the line that's failing, right? So, okay, the cheapest solution, let's replace the seal, slap it back on the bird, we're back in business. But then 10, 15, 20 flight hours later, you pulling it back off because that seal's leaking again. Well, maybe we got something more going on here. So then at that point, you could always say, okay, let's overhaul. But was the cost of those two repairs now, or that one repair and time and pulling it back out, equal to if you'd just overhauled it in the first place, or you'd have completely broken the component down and said, oh man, stage 2 orifice in here is partially blocked by metal debris every so often because this other gear is grinding itself into oblivion and it keeps sending metal chunks through which are cutting the seal. I don't know. You know what I mean?
Right.
So I think most shops would go for repair first.
Mm-hmm.
And it probably goes on the severity of what the damage is or the component is, right? And how high dollar value the item is. And probably a reoccur.
Right. And usually things that lead to overhaul, it's kind of like, this is kind of going deep diving into like your fault isolation, right? It's the problem starts something small, like say you see a leak. Chances are, okay, you either pinched the seal, you blew a seal. Let's replace that. And then the seal is fixed, but now you're starting to get other problems, right? Like your pressure or your temperature is falling or spiking. And then your next possible steps to pull soap, and you find like metal particulates in the soap, then you start opening a whole can of worms, right? And it eventually leads to something like an overhaul. That's in the timeline of an overhaul. Most cases, when you see something small like a leak or whatnot, it's usually fixed by the simplest fix or simplest repair, however you want to classify that. And then the two additional issues that to be considered during a repair cycle is the costs that are driven by the cost of the overhaul or the repair itself, which MVP has talked about. Like, how likely are you to take it to the next repair or overhaul tier or cost? Like, say, example with the grinding gears. Do you want to just spend the money to fix it, like take it apart and fix it, or do you just want to just buy another one?
Right. Yeah. At some point you got to look, and especially as the birds get older, you might go, is it worth, this part's got 15,000 hours on it, and we've, the cost of fixing it at this point, we could almost buy a new one. We might as well just buy a new one. Mm-hmm. So, and it'll have 0 hours and whatever else. So, yeah.
Right. And in most cases, right, whenever you do replace it, you got to say something like return to the vendor or return for repairs or return to next higher tier for inspection and whatever. But that's assuming they have a stock of this stuff, right? I mean, it's all eventually going to go to overhaul so they can diagnose what happened so they can make better products or actually fix it and put it back into the stock cycle. But there's some times where you have no choice but to overhaul because they don't make these anymore, or there's only so many in a pool, like the pool available versus what can actually take from it is much larger. So you're gonna have to actually throw down the money to send it to overhaul, and that bleeds into the next category, which is the turnaround time itself. Right, assuming the material and the labor cost cannot be influenced, now you got to start thinking about the turnaround time itself. Like, how long is it going to take from start to finish to get it back to go through repairs and then come back into your hands for installation?
Right. Is that a day? Is that a week? Is that a month? Is that several months? I've seen it all. You know what I mean? Like, you know, and for most aircraft out there, if it's sitting on the ground, it's not making money.
Nope.
So it's just giant paperweights at that point.
Yep.
Collecting dust.
And another tangent, like with this turnaround time going, now you start dealing with the temptation, like, well, this has to fly, as MVP has alluded to. So now we're going to start seeing like what's more broke than the other, or what plane is more broke than the other. Then that's when it turns into the cannibalization game, where one plane just gets designated as the can bird, and now we're just ripping parts off of it to fix another one, so we can at least continue a cycle of operations until the turnaround time catches up to the aircraft that we just took stuff from.
Yeah, we're waiting on components on this bird, and they're backdated for 6 months, so we're already 2 months into that. So we got 4 months until, at the earliest, that we'll see parts for that. But we can continue flying this bird now with this one component. So let's, scavenge it from there, can it from there, move it over.
Yep.
Continue flying, and then lo and behold, that part breaks on that same flying bird. So, both of them are down, or then something else breaks, and you keep going and going and going, and then 6 months hits, and you're going, "Hey, we got that one part, and we're ready to go." And like, no, we're missing about 6 other things at this point. So,
right. Another off-tangent thing about cannibalization, since we touched on it. How many of you have ever done this where you order a part, like, okay, it's going to take so long. So then you get told to cannibalize another part apart from another plane and stick it in. So you have the cannibalized part in your hand and you're just about to put it into or you just installed it onto the plane that it needs to go to. And then lo and behold, the new one shows up. And so like everyone, common sense would say, okay, let's take the new part and stick it into the bird we just cannibalized from. And then you get this look in your look to your face like, no, I want you to take the new part and put it on the flying plane and take the cannibalized part and put it back in the cannibalized bird. Like, what? Wait a minute, what? And because like in their eyes or in their mindset, right? New is new and new is better. So let's stick it on the plane that has to fly and then take the old new and stick it back to the plane we just took it from. Like, why?
Right. So let's get a little definitive in here. Turnaround time is the elapsed time, or usually an average expressed in days, between the induction of a component, engine, or aircraft into the repair shop process and at the time at which the repair overhaul is completed and the unit certified and released for service from the repair shop facility. This turnaround time definition serves well in the repair facility, usually after passing a bench test represented in the step repair overhaul
process.
Yeah. Now, from an airline's perspective, turnaround time is defined as the elapsed time between the removal of the component from the aircraft and its return to the operator's premises as serviceable. That's been my experience with turnaround time.
Right. So like, I like how it breaks it down. Like, this is what it means to a repair facility. It means from the time we get it to the time we send it back, versus like an aircraft side of the house. Like, it's time starts when you pull it from the plane. So that can be a big difference, because from the repair site facility, whatever, we got the part, we processed it, and our processing time, say it takes 3 days to 3 weeks, depending on the load when we actually get the part in our work queue, versus like an airline's like, this part's bad, take it out now before we break something. So we take it out, and it's going to take days just to get to the repair facility, and another couple of days to a couple of months from the time we get it back. So your separation time and the actual turnaround can be significantly higher or lower depending on what side of the house you're looking at it from.
Yes, exactly. Um, Now there is exchange programs for some providers. You receive a serviceable unit in exchange for the it's unserviceable one with a certain time frame. Um, so if those are offered to you in your facility out there, is they're excellent to get involved with, right? You get kind of a donor. So I know, like in engine replacements, like if you're pulling, like with Pratt and Whitney, right? If you're pulling an engine off and it's going back for a hot section or whatever other maintenance, um, you can, they'll often send you a loaner motor. It might have hours and stuff on it still, but you have a loaner motor, and they say, okay, continue flying with this one. And when we're done with yours, we'll send it back to you. Pull ours, give it back to us, and put yours back on it. And so you go from there. But a lot of airlines, they don't even own the motors; they just kind of rent them, so to speak. You just fly the shit out of them, almost like leasing.
Mm-hmm.
You just fly the shit out of them. When something happens, send it back to the manufacturer, and they'll send you a new one. People say, well, man, wouldn't it cost less to own them outright? Depending on the size, but if you're a major airline operator, it's probably way more cost effective, especially on maintenance costs. To every time you got an issue with it, you go, hey, call the OEM, tell them we got issues, and it's their responsibility to fix it, type thing.
Right, and
yeah, you're losing money because your bird's down, but if it's severe enough, they're going to show up with a spare motor.
Right, and usually when something's leased, they have that baked into the contract where it's like, if something happens and it's within this realm of instances, then we'll cover it. Versus like when you own it outright. When you own it, it's yours and you're responsible for everything, right? It's kind of like solar panels, right? Is it cheaper to lease it or is it cheaper to just own it outright? There's pros and cons to both, sure. But especially on aircraft side of the house, when something's leased, you have some form of a backup. It's as far as repairs and lease and exchanges are concerned. So it gives you a little bit of insurance. Like if something breaks, you're at least assured that at some point there is going to be a replacement, unless they just don't make them no more. But owning them outright it can be good because you're not constantly paying for leasing costs. But then when something breaks, you have to own up to it up front.
Yeah, I mean, you're pulling that out of your maintenance costs, and now you've got to start supplying or stocking your warehouse with all the seals, components, whatever is needed for that particular motor. Whereas, I mean, yeah, you might keep some small stuff, right? Because even if you're leasing, they're not going to waste time calling the OEM out there to replace a couple of seals on a gearbox. They're just going to have the line mechs do that in between gate changes.
Right.
But it's the major inspections, like hot sections, right? The big money stuff. The motor's got to come off. You got to change out fan blades because birds strike or whatever else. And, that's where it gets a little more feasible, I think, for the airlines to manage. Especially, like I said, leasing, it probably works out better if you're a smaller, maybe Part 91 or whatever operator. We only have a few jets and you're only flying a couple hours a month. You're not putting, dozens of hours daily on your aircraft. Your aircraft might get 10 hours a month. It's probably better to own them outright. But if you're operating several hundred aircraft worldwide and they're just racking and stacking hours, I imagine it's probably a lot more money feasible to lease,
right?
Especially when it comes to motors.
Right, exactly. And when it's like, now that you touched it on the exchange program, this bleeds especially into turnaround time is the fill rate itself, right? So although turnaround time is important, the fill rate has to be extremely scrutinized. Like you got to carefully monitor that stuff. Because, for example, if your turnaround time calculated statistically would determine how your stocking levels are done, if the airline experiences multiple failures inside a specific time frame, it will result in a stock drop. And then how soon can you get those stock items replaced?
Exactly. Which in most cases, I would recommend having a contingency stock
Yes.
identified somewhere. But here's the other thing: depending on what that is, if it's hazardous waste material, you might be limited by federal laws to how much you're allowed to actually have on site at any one time. But you could go for months and have, okay, I got 5 bottles of this whatever has material here, um, and we haven't had to use it, so I've had to waste it because it expires, right? Has stuff has a life expectancy to it,
Right.
and okay, it's expired, so eventually somebody's going to go, how come I've wasted in the last year? I wasted, $18,000 on this has material. You keep saying we need 5 bottles of in stock, but we don't have any. But next thing you know, either uh, get a bad batch of a component that requires that has material, and you got multiple trips across the country, your jet's going on, and it just next thing you know, you've bled through those 5 bottles quick, and but you already got your bag smashed, so now you're only keeping 2 bottles in stock instead of 5, and now you're, you know what I'm saying? So it's a really hard line. I feel bad for supply personnel. It's a hard line to ride.
Yep.
Um,
Well,
because
especially
you're damned if you do and damned if you don't.
right, and especially with something like hazmat, like they not only they have a shelf life, they also have a use life. So, like, say, like you got those 5 bottles and you pop one, now you have 24 hours to use it all. Otherwise, it's trash.
Mm-hmm.
Or in some cases, right, like you can open and close it so many times. Like some certain chemicals, like it even says on the bottle, like throw away after day 3 since opening or something like that. Some of them, like as soon as you pop, they're two parted or they're multiple parts, and then once you open it, you have so much to mix them together before it's not as effective anymore. And then, like you said, like you're limited by how many or certain types of hazmat you're allowed to have on site, and then how long it's going to take for them to produce more to send your way. Or like say, like bigger ticket items, like say gearboxes, transmissions. That's kind of the same thing. Or or engines. Like you're out one and you had a stock of 2, but you need air quote 3 to maintain a capable stock. But the next third engine to come out of the overhaul line is 6 months. So
Right.
you're
And, and then also add in COVID pandemic times. Oh, well, the manufacturer of said components or product is running on minimal staff. So typically it was a 3 month, with full staffing before COVID times to get these products in. So you could base around that. Okay, every 3 months we're going to be getting a supply of this. I can build my usage reports and whatever and fill rates from there. But now it's an average of 6+ to get
yep.
the components back. So, or the products in. And then you get people harping at you, hey, we need this. Well, I ain't got it. Well, it's your fault and you haven't done this. This is hitting very close to home for projects I've got going on right now. And you're going, what do you want me to do?
Yeah.
Well, there's no contingency. Well, there was, but we had to deplete that because we haven't got anything back. Well,
Right.
figure it out. You should have multiple contingencies, but then I'm going to get my dick slapped because I have multiple contingencies and I didn't use it all and I had to waste $5,000, $10,000, $18,000 worth of product because we didn't use it.
Right. And then
But if
vice
we'd
versa.
had that, this wouldn't happen now. So that's where I go. I feel bad for supply because you're damned if you do and damned if you don't. No matter
Right.
what you do, it's fucking not right.
Right. And then when you start exploring different contingencies, right? Some of these might include using different vendors that have never been approved before. So going through that pipeline to get these vendors vetted, approved, and in process to build you replacement, that could take you just as long as it to get the fill rate from the previous vendor, which you had that you originally had a contingency for. Like, what the fuck do you want?
Right, but at least you have another route. What if it's a single source vendor?
Yes.
There's no other option, right? They're the only manufacturer producing said product, and it just sucks to suck, nerd. That's exactly what they tell you too. Like, I don't know, it's COVID times, deal with it. And you're like, okay.
Yep.
But people higher in the chain who don't have to actually deal with it that much, all they see is birds sitting and whatever else. And you're like, I don't know what you want from me. Like I can only have so much on hand. They're not making so much anymore. We've upped our workflow, so we've used more, and you guys added in several road trips that weren't previously planned. Like, it's not a single point failure. You guys are trying to make it here, but we only have a single source vendor, and they're telling us that we'll get it anytime from 6 months to when you fucking get it.
It's sad, but it's so freaking true. And I see a lot of pain in this, especially with smaller vendors or smaller airlines, because they got to compete with all the big ones who just buy it up in bulk. And if it's coming from a single source, like, well, when's the next one you're going to have available for us smaller ones to have readily available? Oh, anytime between now and whenever the fuck you get it. Like, thanks, I guess. Let me just go and tell it. Like, just, can I quote you on that? So when my boss comes bitching at me, I can actually say this verbatim. So it really sends it home, like, just how slow things are going.
From my experience, you tell the big boss that and they still don't care.
Yep.
It's your fault because of this. And you're like, oh, okay.
I see where we're going here. You know, I the writing's on the wall that one. Now, this is assuming, right, like the provider or the manufacturer, supplier, vendor, whatever, is actually going to give you a conforming product first try. So that's a whole nother mess we're talking about. But what it does go into is scrapping. Because if anyone has ever received a part, or you're an overhaul facility and you get a repair, there's going to be a pretty good chance that you might have to scrap it. Now, what does that mean? Usually upon removal, dictated by an unscheduled or a scheduled event, the component is routed to a shop, a repair or overhaul facility, and then under certain conditions, depending on whatever their specifications tell them, it's not economically feasible to try to repair this part. Like, there's just too much work to do that's going to cost a shit ton of money and too much resources and manpower. They just said it's there's just different words for it. One of them is beyond capable repair, or beyond capable maintenance, or beyond capable overhaul. It's something to the
beyond
point like
economic repair.
Yes. Yeah, beyond economic repair. So it's like beyond economical repair is like the ratio of repair cost versus the value of the part itself. So imagine, like, say you got a $500 part. Let's throw a number. The part's broken. You take it to a repair facility or overhaul facility, and they say, like, this part is so broken, it's going to cost $1,500 to repair this $500 part. So at that point, you're like, well, fuck it. Just make me a new one. If it's going to cost $1,500 to make a $500 part, I'm not going to pay 3 times it's going to take to repair something that's possibly going to break again. Just
well, in most organizations, and especially the military, right? They have like dollar amounts assigned to that. So let's say you have an incident with the aircraft, and if the damages to certain components are less than like 100 to 150 thou, or even 200 thou, they just wipe their hands of it. All right, just get us a new one then.
Right.
Because the components of damage obviously are less.
Right. And the rule of thumb for most repair facilities, repair overhaul mechanics, or even just the bean counters that determine whether to overhaul or not, is if a part exceeds 60 to 70% of its value, then it's considered beyond economic repair. Just scrap it. And that kind of goes into what you're saying. Like, if it doesn't pass a certain threshold, whether it be this dollar amount or this value of the part, Bob, I wash my hands, clean up the whole event. Just give me a new one.
Yep, exactly. Okay, so let's see. Typical value for this threshold is set at 60 to 70% of the cost of the replacement.
Yep. And
there you go.
Yep. And then again, like, this is all just based on the economic standpoint of it. Like, it's going to cost more for me to fix it than it is to just buy a whole brand new one. Now, they sometimes that's also come into turnaround time too. Like, the cost is there. Like, say, like, it's a $500 part. It's going to cost me $550 to fix it. But your turnaround time is so long that the weight is not worth it, and you just like, well, whatever, toss it, or just stick it in the shelf until we eventually get to it, and just manufacture me a new one if that's even possible.
Yeah, and as the older the bird gets, you'll find that it's just not the case, right? There's no replacements left, so you only have one choice, and that is to overhaul the part. But good luck finding somebody around still who still has that expertise or wants to waste money and time, or might be losing money, right, on that manufacturer. You say, okay, hey, manufacturer, you guys are the producers of this what's an old bird we could use? This Saberliner, right? Mm-hmm. Okay, well, Saberliner hasn't been manufactured since, let's say, 85 or whatever. Mm-hmm. Well, we've developed 10 different gears since then. Yeah, but we have an issue with this one now. Can you guys repair it? I mean, yeah, but we're losing money because there's all this newer gear we got to attend to and manufacture. Like, it's not economically feasible for us. Like, if we get to it, sure, send it to it, and we'll put it on the back shelf. And if we get like a trainee in, maybe they can do it, type thing. Yep. But or they say, okay, we'll do it, but it's for us to take away some of our best and most senior guys who have experience on that from other projects, it's going to be triple the cost. Yep. Shit, but that's some of the issues you run into.
Right. And I'm just going to throw it out there is whenever a part gets overhauled, that doesn't mean it's considered brand new anymore. I mean, there's certain pieces of it that are, but it's kind of like when you get stitches, like, yeah, it's fixed, but now you have like this soft spot, right? That it's more prone to more failure. So
you taking a shot at me right now? Is that what's happening?
No. but honestly, like, not all parts that are overhauled, they're considered brand new. And honestly, from the time you take it off the aircraft, you just depleted its useful time, because now we have to do stuff to it, which is outside of the brand new aspect of it, right? Now, this is going deep into the weeds, and we can actually bat this around a bunch of times. But once it's overhauled, right, it's set back to zero, but it's not like brand new zero, right? It's now like this new mathematical equation, like timeline now. Like, okay, now it's overhauled. Now you have this much time left before
since overhaul.
Yep. So it's not considered brand new. Let's just put that out there, because like,
there's only 5 hours on the engine. Well, actually, no, there's 5,005 hours on the engine. At 5,000, it pulled off for overhaul. Now it's been back into service. So, yeah, we're tracking only the 5, but in reality, that engine has been around for 5,005 type thing.
Right. Yes, that's a better way of putting it. I can't believe I just fucking bat around the bush about that. Anyways. One big one too, besides the scrap rate, is like, say, like you have a part and you send it to the repair facility and you have no idea why it's doing what it's doing or why it's failing. That's when you run into the no fault found or could not duplicate scenarios. And for everyone and anyone that has to deal with these, it drives everyone off the wall at every step of the way. Because like, you got the technician who says, I don't know what the fuck's wrong with it. It's a fucking anomaly. It's Project X. It's something. If there's a fucking gremlin in here somewhere and it's just fucking with me. And then you get it to the repair facility where they don't know what the fuck is wrong with it. Like, what do you want me to do,
friend? Fine, whatever, yeah. Some parts are just lemons, man.
And I see this as lemons. I see this especially when it comes to electronic components. No disrespect to avionics guys, but anything that deals with electricity gets very finicky once it starts breaking. Like it arced across and shorted something out, or the magnetic polarity in certain components, it got reversed, so now the whole thing's fucked, or something to that effect. But
electricity or electronic components and heat don't go well together. So let's say your fan on the component was underperforming, and every time you cycle that component goes through a work cycle, it gets right on the cutting edge of being overheated, and it's starting to break itself down. It's starting to kill itself is what it's doing. So now things are starting to go intermittent.
Right. That's another good scenario. I was thinking along the lines, especially with something that has to deal with magnetic polarities.
Oh yeah.
Like say compasses, for instance.
Or you could say, okay, hey, flying around down here in Phoenix, and God, this thing keeps acting up or whatever else, and so the repair facilities in Seattle. So you take it up into Seattle to get it worked on, and they're like, we don't have no issues. Like our test pilots are flown around. There's nothing. We bench tested. It's fine, but it's 125 down in Phoenix, and it's 40 or 55 up in Seattle. Like it's. Mm-hmm. I've seen that happen before too.
Or I've seen scenarios where, especially with inverters, like aircraft inverters, moisture, or like the cables, like the pins sink back just enough to not make full complete contact with the component.
Oh my God. There's so many times I'm like, mother, what is going on? And you just grab the back of the cannon plug and you just jam the fucking wires forward, and you're like, ah, but that was just enough to make it work. You didn't realize that at the time, but as you get more experience, you're like, oh, that's what it was. So like now I've sort of gotten into the practice of I'm like, so I've cleaned the connection. Okay. I pull it off and I, spray the connections with some cleaner. And I'm like, okay. And then I'll grab like a pin installer, one of those little, I don't know how to explain. They have like a little U channel.
Yep.
Basically you can install the pins or uninstall the pins, and I'll go and I'll just get to the back of the cannon plug and I'll just push all the pins forward. I'm like, okay, did that and that, put it together, see what happens.
Yep. Oh, you're talking about the pin pullers, right?
Yeah, except
like they're
the ones used to install.
Yeah, they're some of them are plastic, like they're green, white, red, I think it is.
Yep. Those. And I'll just get in there and push some things forward and hope for the best.
Yep. So that was what we had. Like these inverters, like they kept failing. You're like, what the fuck is wrong with these things? And we keep sending them back to Overhaul. Like something's wrong with these inverters. They're not working, or they're shorting out. They're not providing enough power. And every single time they'll send it back to us like, what the fuck are you talking about? Like we bench test these things and it's fucking fine. And then as soon as we install it onto the plane, like there it goes, it's not working. Like what the flying fuck is going on with this thing? And we've had experts galore come take a look at these planes as to why the hell these inverters weren't working. And one of the causes was, like you had said, like the contacts weren't fully engaging with the component itself. So it had to give it was a very minute gap, like real small, like almost you couldn't see it, but it's just enough to not have the electricity bridge right. And then that's what was causing the failure. Like WTF, man, what the fuck is going on? And that's majority of the factors that lead into no fault found problems, especially when you send it to the facility, is you have inaccurate flight line or line maintenance diagnosis. Like, I just don't fucking know. Or their fault isolation manuals are not caught up to speed onto that component, so they have no idea how to accurately troubleshoot this shit. How many times we ran into that?
Yeah, tons.
Or like say you remove the component so many times on and off for reasons like say cannibalizations, and that you induced a fault somewhere. Or you have incomplete or inaccurate bench testing at the repair facility. That's rare, but it happens. Or you have inability to duplicate the circumstances, i.e. trying to simulate air or in-flight conditions on the ground. It's just never going to fucking happen.
Yeah. At 50,000 feet, we keep getting yellow fault light indication code, yakety yak. And you're like, I'll never, unless I put the thing on stands and put a air data system on it and try to run it up to 50K, but that's about all you can do. But I don't know a lot of small repair facilities that have that kind of test equipment sitting around.
Right. And then going off tangent, like whenever you put air data systems, like you actually simulate flight and you run an engine through, there's a high chance you're going to bypass a lot of the ground control features that protects it from you doing some dumb shit like that. So you really have to monitor it when you simulate in flight on the ground with air data rolling through it. Because I remember this one instance when we did exactly that. We simulated flight with air data rolling through it, and we motored right through the ground control safeties, and we almost overheated an engine because we blew through those safeties. I want to say like it almost pegged out. Like we caught it just in time, but it was just so easy how that was happening that had someone with a trained eye not have been watching, we would have fucked that engine up so bad.
Yeah, I mean, and sometimes that's what catches it. It's just a seasoned person, but
Mm-hmm.
and they just had to be looking at the right place at the right time. Or the only reason they knew where to look is because they experienced that firsthand down the line, and the motor, they did lose the motor or transmission, and then like, oh, now I know what to look for in the next one.
Right.
That
And
was
then
costly,
and then like you said as before, some parts are just lemons. You do have those
which is
that
a
are,
rogue unit.
yeah, they're just broke for whatever reason or another, be a manufacturing process, an installation process, or a removal process. Something happened and it's fucked. Like that's it. That's just how it is. And you get those every so often, but to use that as like your sole excuse, like, oh, how many times have we said like, oh, this unit is fucking cursed, and it really wasn't. It's just like bad troubleshooting. But you do have those moments where you have a rogue unit that just does not want to be fixed.
Well, and like usually when especially if there's duplicates of that component, I'll move it from position to position to position. Like, let's see if the fault follows.
Right. And that's in most um fault isolation manuals, it'll say something to that effect. Like, does the condition follow the part, or is it isolated just to just that one area? Because then if it doesn't, then it's something in that area that's fucking up the part. And
Yeah, you
for
go,
all you,
okay, I moved it over to the number two position, but it's operating normal in number two. So let me put it back over to number one and start following down, and then put the number two and number one. Oh, the good one that was still on two is now failing for some reason in the number one station. So let's start moving down that line and go next, follow the wires and go next component down.
yep, yep. And then let's say like something's wrong in that area. Say it doesn't follow. Now you've induced problems into two different components now instead of one. Oh fuck!
Oh man, yeah, you're like, I moved it over there, and so the first one turns out we figured out the first one was fried. In our troubleshooting, we fried the second one. So
So now we're down two. Like fuck.
down to, if you can just go ahead and send another one of those, two more of those, that'd be great.
Yeah. Well, yeah. Two of them. One is great. Two is better because we need this for minimum flight safety reasons and stuff. The plus side of it is if you ever do discover a real rogue unit, that could lead to a potential for improvement because it could be a fault or a gap in whatever process it is. Like the manufacturing process, like they didn't inspect a certain lot correctly or they just didn't at all.
Well, I've seen that a few times as well. I'm glad you brought that up because, like, and especially when generators, it seems to be a common occurrence with generators. But you're using a specific manufacturer's generator, and for decades you've had no issues. But unbeknownst to you, that generator manufacturer you chose a cheaper manufacturer of components that they use to build these generators, and so now you just have you're getting faults left and right, and you're going, what the hell? We keep shitting generators out. What's going on? For decades, these things are rock solid, man. We'd fly them always to their high time, pull them off, and they go back for overhaul with no failures in between. And now we can't even get off two flights in a row without crapping one out. Like, what's going on? And so, yeah, and then that's when you send your investigation team, your quality supplier investigation team down there, and that's where you figure out, you're like, oh, they were using so-and-so company to produce this, to acquire their copper from, and now they've gone with this company over here because they were half the cost, but also half the quality of the product that they were receiving. So these copper lines are breaking or snapping under whatever.
Mm-hmm. And like I said, like you mentioned, like sometimes you won't even know this or you won't catch it until you encounter that one rogue unit, right? Or that one is like the gate opener. You just start getting a flood of them. I'm like, is it a lot problem? Is it a batch problem? Is it a supplier problem? Or is it the aircraft itself? Is it the aircraft the one that's frying these units or what?
Well, and usually it won't even be the first one. You're like, man, this thing shit is just a bad generator. Okay, you replace it, and then you're like, man, we crapped another one out. Man, it's got to be the bird at this point. And next thing
Yep.
you know, you get four more guys walking off and say, hey, tail numbers, X, Y, and Z. Uh, they're all shitting their generators too.
Yep.
Wait, well, how are they acting? They're doing this, this, and that. Oh, that's exactly what these ones have been doing. And then that's when, okay, we got something deeper with the generators going on.
Right. And the usual case for that is like usually you'll start like this big investigation with the supplier, the OEM, the vendor, whatever the case may be, and you can actually start building trends of all these different tail numbers. Like this is what was happening. They're slightly around the same age, or they're slightly newer from each other. They're from different airline companies for that matter, but they're experiencing the same exact problems. And
Mm-hmm.
usually when that happens, that's when you start doing a purge, right? This great purge where like any and all parts of this, especially from this, usually they start small, right? They say these serial numbers. Actually, no, they'll just say like all of them, ground them all, and they'll say just remove all the generators for inspection, and then they'll slowly dial it down to like, okay, we need these serial numbers to go up to inspection for investigation and such. And then that's when they start deciding if they're gonna remove that lot or batch or whatever from stock, or just start scrapping them if they've been overhauled or produced within a certain time frame.
Right.
And then that leads us to our favorite one, which is systems obsolescence. I feel like this really hits home because a lot of components and aircraft that we have seen have all long since been obsolete, or they've had components in them that's been long since obsolete, and it wasn't because they were bad parts. It's just they just don't make them no more. Like whatever, it was a single source vendor, and then they just said, "We're not doing this no more. We're gonna go do something else," and then now you're screwed because now you have to find some other means of producing that same part for just a
Or you have a newer bird, but they throw Desert Storm era components in it, and you're going, how the hell are we using? We all know there's better stuff out there now, right?
mm-hmm.
Like, yeah, but the so and so the operator this back in Desert Storm time, they bought 50,000 of these units, and they got a warehouse sitting in freaking Nevada somewhere with 30,000 of these, and they want them used up. So we're going to install them these new birds. Like, why are we? What?
I was like, why? Why are we sticking old shit in new planes? Usually it's the other way around. We stick new shit in old planes.
Yeah, that's again my real experience.
Oh, that's so terrible. But usually, like system obsolescence, it refers to like the component itself has hit its endpoint, like its end of service life, and that's usually determined by the producer, the supplier, the vendor, the manufacturer, whatever. They're the ones say like at this many hours or this many operating time, it's dead, just done. Like get rid of it, or return it to us so we can get rid of it, and that's it. That's the end of it. And they usually do that along the lines like they'll send out some kind of bulletin, like an engineering memo, a service bulletin, or end of life message saying your component is hitting X amount, so you might want to dial back its operations. Otherwise, this thing's gonna shit itself when you don't want it to.
Yeah, so either find or you work on looking for an upgraded system to replace that, or you're going to end up just grounding the bird altogether. And
Right.
that's why you see them out in the boneyards, just stacked up, wasting away, used for pulling panels and skins and whatever else they might need to off of them.
Right. And usually when something goes, is starting to hit its obsolete time or its service life, when you get those messages, right, you're like, well, how does this incur costs? Like, well, one, because now you got to start figuring out how much it's going to take to replace it. If there is going to be a replacement, how long is this thing going to be down for once you actually start having to factor in to pull the part? And then how is this going to factor in for all the other scheduled and unscheduled stuff on the plane itself once this thing goes obsolete? Because depending on what it is, there can be a downtime of a day, maybe a couple days, or sometimes months, depending if it's a more critical component.
Exactly.
So
Exactly.
Yep. So best practices to reduce overhaul repair time costs. Optimize your turnaround time. This is vital because if you know a part takes 6 months, don't be trying to schedule something in less, right? Or don't wait
Right.
till month 5, week 3 to figure out that you need to replace something.
Yeah, be proactive, not reactive. The next one, choose wisely whether to repair or overhaul. Bear in mind that the repair can lead to more single events in the long run, but also evaluate if the lead time to get a new part meets the operational requirement.
Yes. Minimize your no fault found rates and pay attention to the fees in the no fault found rate fees in your contract. That's assuming you got one, right?
Right.
Basically means like if you're getting a large rate of no fault found, that might be a good thing to look into because there might be a lot more stuff underneath that you're just not tracking.
Right. Or you go, how come I've sent 3 of these same components and they keep telling me no fault found? What are you guys actually doing out there?
Right.
What are you troubleshooting? Are you just walking in here and telling me the shit doesn't work and you've tried everything? And I'm going, okay, send it back.
Yep.
Establish an optimum for your BER ratio and determine if your BER policy applies and considers allowing flexibility depending on certain cases.
Yep. So like that's the beyond economic repair. Like, is it
Mm-hmm.
more economic to repair it or replace it? That's going to be something you got to weigh out and then also factor in for your actual cost because sometimes replacing it is going to be more expensive than repairing it and then vice versa. And then list down the priority items which cause the majority of your costs. Use categories to find weak points and involve suppliers. So this goes into the what's called the Pareto Principle, where 20% of your or actually 80% of your headaches is caused by 20% of the sources.
Yep.
So if you can narrow down what that 20% is that's causing 80% of your problems, that really dials in until on what kind of items you need to prioritize as far as risk and cost. Explosion.
For all commercial agreements, consider total turnaround time of the part in question. Looking only at the shop's turnaround time will leave the airline exposed for the time that the part is in transit between the airline and outside repair shop. So, if the shop's total turnaround exposed, what do you think that means?
I'm thinking that meaning like just don't see it as just a shop thing because you also got to kind of consider what the repair facility is doing. Because yeah, their turnaround time is 3 days, is say 3 weeks, but they're backed up for 6 months. So you got 6 months on top of 3 weeks, and then also
Oh, okay, I see.
and then also the transition time from the time it's done to get to you. So
Yeah, so if the part has to go across customs, so let's say again for a Pratt part, it's got to be sent up to Montreal.
yep,
Um, okay, yeah, like you said, hey, it takes us 3 weeks to do this. Unfortunately, we're 6 months behind, so we'll have it to you in 7 months. Um, and then okay, it's done. Okay, but also mind you, it gets stuck in customs for 7 days. Once customs releases it, then takes however long, whatever shipping provider you use to get it back to your facility. Gotcha.
right. And that kind of goes into the next point, which is use your fill rate in addition to turnaround time. That's more or less what we just described. Rationalize the supply chain management policy, either pick and choose OEMs individually. This may create some overhead costs or consolidate into an all one stop shop provider. Now, there's pros and cons to both.
Right.
Uh, but if you can do it to a single source or like a single source that has different subcontractors out there, then by all means, because if you're just going pick and choose, pick and choose, pick and choose, there's going to be a lot. You're going to run into a big scenario where that one goes out of business and now you're having to run the round robin to find a suitable replacement.
Uh, Carefully evaluate all implications before using non-OEM products, repairs, and new technologies during the term of lease. They may minimize costs, but they may cause problems at redelivery.
Ooh,
Oh,
I, I think we felt that quite a bit sometimes, where like we're using air quote aftermarket parts, you know, or
yeah.
parts that are experimental or in test, right? And he's like, oh,
Mm-hmm.
this is the new up and coming thing. Oh, sure, let's try it, right? And then it it minimizes it, but then you like they haven't tested it for the long run, so now you're the guinea pig to figure out where all the problems are.
Yeah. Been through that. Still going through that.
Oh,
Here, this is supposed to replace such and such system. Put it in here, and we'll monitor it over the next 6 months and see what it does. I mean, I think it happens with any new part. It's got to be tested and vetted.
right. But usually when you buy it, it's already been. You're assuming that it's been tested, right? But it's kind
Mm-hmm.
of one of those like wish-washy sales pitches, right? Like, oh, this has been tested at our facility, right? Or
Mm-hmm.
it's gone through phase one of tests. Now we're going to phase two, but we didn't tell you that, and and then now you're discovering it as it's breaking. uh, Consider all costs, i.e., holding, cost of inventory, which we've explored so well, cost of administrative overhead, repair costs, reliability of time on wing, and the freight or the
Right.
transportation. Ooh, most def. I mean, we kind of explored that a little bit with inventory. Like you're only allowed to have so much, or it takes a while for you to get so much, or your operations ramp up. So now you got to build more or collect more. That definitely is gonna go. It's gonna spike a lot of shit.
For sure. And then the last one we have here is implement Six Sigma methodologies to minimize overhaul and repair costs, uh, to reduce no fault found rates for components with the highest no fault found rates, batteries, emergency transmitter packs, and or reducing turnaround time.
Ooh. Six Sigma. That's a big beast in itself. Like a lot of
Yeah.
people say that they understand Six Sigma a lot, and for the most part, they get the general gist. But to actually deep dive and do all the requirements that Six Sigma asks of you, it might be more than what you were planning on when you actually undertake it. So if you are gonna do Six Sigma, just say like you just be don't realize you're gonna be in it for a long haul, especially with the amount of analysis, depending on what it is, to actually solve. And in some cases, there's never going to be a solution. So it only apply it where you feel it's going to help you best. Because if you apply it to a broad problem, you might be chasing your tail for a good amount of time before you discover that you were fucking up in the first place.
Yeah. I'm not going to sit here and pretend like I know anything about Six Sigma. I really don't. So,
I mean, to be honest, like we've done it before, we just never actually applied it. And a lot of stuff with Six Sigma involves numbers, which not a lot of mechanics like to do. But
I'm raising my hand over here.
same here. Excel's my friend, man. I'm telling you. And that's how I do any and all of my math nowadays is Excel. It's like, Excel, how do I do this? And it just figures it out for me. Like, oh, thanks a lot, bro. Thanks, Fran. Or what's that? I forget this one program where you just take a picture and it solves it for you. I
Oh,
forget
yeah.
I forget the
Yeah.
name of
Yeah.
that app, but that shit was such a freaking boss, man. Like my kids would like show me this problem, like what the hell is it? Try to ask me to take a picture of it. It just like breaks it down, like, oh, holy shit,
Yeah.
there you go.
I have to ask all the new kids because I didn't have that. Then that didn't exist for me when I was in school. I just failed like they're like you're supposed to.
I get called a failure every time you come home. Oh man,
That's funny.
so that's a lot of stuff, and that's just repair cycle. There's so much more stuff of off wing support, but this one is like I feel like it's so important and critical, especially with how we are nowadays with the pandemic still in effect for the most part. Is a lot of this stuff has affected the repair cycle time, and for all the airlines out there that had to ground themselves for so long and then bring themselves back up and then pick back up on operations which they weren't prepared for with minimum personnel, that just really aggravates the scenario of the repair cycle itself.
Agreed.
Agreed. Final thoughts on this MVP.
uh, Well, it's a lot to cover, right? It's a lot. You can go in more in depth on all this stuff. The supply chain for any organization, especially a large one, it's a beast of a system, and I know we've kind of just skimmed the surface a little bit, and hopefully it helps you better understand when you're calling supply and they don't really have a solid answer, or they're giving you something like, hey, but it's not just on them. I mean, they're trying to deal with vendors and these policies and these agreements and contracts. So I feel for them a lot, because that just sounds gross. You know what I mean?
Very gross.
Very gross. Just being honest, it's a bear of a system. So get as knowledgeable as you can or as you want to about the supply chain management. Hopefully it'll help you better understand how your organization's operating and why it takes so long for certain parts and why it doesn't for others, and learn the cost of things. And hopefully that'll help you better in your decision making when you're going to your boss and saying, hey, I've got this part. I've put it through the ringer of what I can do and what I think I can do. Here's what I've done so far. Am I missing anything? No. Hey, we might need to send it back to the manufacturer, and understanding the repair versus overhaul and saying, hey, boss, I've done this, and that. I think it's more than just a bad seal. I think there's something else going on in there. Help your boss make the decision. So all this will help you help yourself.
Right.
Eventually.
Right. And like Kevin P has alluded to, like most of this stuff, as a line mechanic, you won't deal with a lot of this, or you're only dealing with like the first level of it. But just understanding where you fit in the whole chain of events makes you more knowledgeable how it works, makes you more knowledgeable what needs to happen next. And then it answers a lot of questions like what MVP brought up. And should you ever elevate yourself to the level of a director of maintenance or a line chief, or quality assurance chief, or whatever the case may be, this is stuff that you will have to get savvy with, because this is how you plan out and schedule out everything. So giving you the keys to the city and what it takes to go for career advancement. So with that being said, I think that's a good point to close. If you guys have any reactions or other stuff to add to this stuff that we have missed, please by all means shoot us a line. Let us know your experiences of this stuff and some of the common trends or problems that you have ran into while doing some of these things.
If you have any general questions, feel free to hit us up on the social media. We'll help as best we can, or try at least find an answer.
Most def. On that note, see you next time, everybody.
Bye, everyone.
We'd like to take this time to thank our patrons for supporting our show and allowing us to continue to make episodes, maintain our gear, and create merch for all of our listeners, with special thanks to Erica Lamont, Chris Hawkins, Ryan Frushauer, Dan Schubert, Jenny Dignan, and the ladies of the Dick Talk and Mimosas podcast. Thank you all so much for your support and patronage. Visit our shop at cancelformaintenance.com and grab some swag to show off both your support for us and your prowess as an aircraft technician. If you have ideas for the show, or you'd like to be a guest on the show, visit our contact us section and send us a line. We will do what we can to get your ideas or yourself on the show. You can also follow us on social media, such as on Facebook at Cancel for Maintenance, Instagram at Canx, that's CANX for Maintenance Podcast, or on Twitter at CXMX Podcast. Check out some of our affiliates like Rockwell Time, where they make both rugged and classy watches to fit your lifestyle. Use the code CX4MX and save 10% off your purchase. Support us on Patreon. Our patrons get exclusive perks such as access to our Discord, discounts and early access to merch, special patron-only episodes, and so much more. Thank you again so much for listening, and we'll see you next time.